Hello, electronics enthusiast, and welcome to my channel, Crazy Gamers Games. This is going to be the second video in my basic electronics. Um, Basically, going to give you the knowledge and information you need to go out there and make simple electronic projects, whether it's around the house, whether it's for your hobby. I play hobby games with miniatures, and I like to put LEDs and electronics in the miniatures. So I'm working on a rather large electronic project, and I've had a lot of people ask me, how are you doing that? So basically, I'm doing this series to teach electronics to the average person. A lot of people already know this stuff, but I'm going to keep it very simple because I want people who've never ever worked with electronics to come out with the comfortable knowledge to put LEDs into something, maybe some small motors, work with a microcontroller, um, work with relays to turn things on and off, and just basic concepts of how to make electronics not a scary topic. So to do this, I'm going to be following this Make Electronics book, second edition by Charles Platt. It's a very good book. I've read through most of it. It comes with 31 experiments, but the best part about this book is you can buy component kits that have everything in the book that you need. Now, in my previous video, I went over component kits from Pro Tech Trader. They have 3 separate kits um, that go through. You don't need to buy them all at once. You buy the first one. I believe that gets you through the first 11 experiments, maybe 13. And then the second one gets you through a chunk, and the third one gets you through the last larger ones. So right now we're starting at the beginning. Um, Basically, the beginning talks about some changes that went on second edition, changing some stuff to get harder parts. Um, it talks about different materials you need, but in the beginning of every starting, I'm going to tell you what you need. And um, if you have one of the component kits, then you're going to have everything you need. If you don't, I use a simple list. I'm going to tell you what you need. For this first experiment, you're going to need a 9-volt battery and a multimeter. These are from a sponsor, Illumini. These are very good meters. They're graphing multimeters, which means they have an oscilloscope, but you don't need a meter like that. You can use one of these meters. These are like $3. Um, you don't need a fluke. You don't need anything. I use these $3 meters to measure current all the time. I love these $3 meters. They're um, they're fantastic. Also, there's other meters that are low in price in the $30 range that do a lot of good stuff. I'll show you one of them in a future video. But right now, I'm just going to use my Lumini meters. Um, Another thing in this series, um, I'm going to have multiple meters. I have multiple meters, 3 right here, and I have a couple more set up. You do not need more than 1 meter to do anything in this book. I'm going to use more than 1 meter for the teaching aspect of the electronics. Instead of spending 40 minutes hooking a circuit up and then changing the meters to measure different things, whether it's current, voltage, or ohms, I'm going to have multiple meters set up to do that. Like these yellow meters, they'll be my dedicated current meters, just because I don't like running current to more expensive meters. I'm not a fan of that. And then 1 meter will be set up for voltage, and then 1 meter will be set up for general ohms, diodes, voltage drops, and things like that. But for this first part, you need a 9-volt battery. It's an Amazon Basics 9-volt battery. They do not sponsor me, but their batteries in bulk are a very, very good bargain. And a multimeter. And then coming up next, you would need a AA battery. Again, Amazon Basics, fantastic value in bulk. And you're also going to need a single AA battery holder that has the leads on it, as you can see here, and some alligator jumpers, little alligator clips. They got a little clip on them that you can jump from one section to another. And then some fuses. I recommend 1 amp or 3 amp fuses. Automotive blade fuses work great. Let me show you what they sent me with the kit that I have. I'll show you here. Here's what we have here. This will be for the upcoming experiment. This is a 1 amp blade fuse right here. So I'm telling you this now because that'll be the next video. We'll be using these items, so if you want to follow along. I know in the last video I didn't tell you what you would need for this one, but it's basically fairly simple. We're going to get familiar with using a meter, and then we're going to look at the 9-volt battery, measuring voltage, and things like that. But for the next video, experiment 2, you will need some 1 amp fuses. You don't need blade fuses. You can use glass fuses like this. These go all the way down to 200 milliamps and up to 15 milliamps. This is basically all you need, and you can still clip alligator clips to the end of them. And these, in the next experiment, you blow a 1 amp fuse and the experiment's over. I'm actually going to demonstrate how different amount of currents blow different fuses. So I'm going to blow a few different fuses. They're very, very low cost. A couple dollars for 100 and something fuses. Plus, it's always good when you build circuits to use fuses. I use power supplies to power all my projects, but you don't need that, and I'll show you how to do it without a power supply. A lot of the things I have you don't need for these experiments, and just remember, I'm just using them for the teaching aspect of these videos. So basically, in the first experiment, it's called Taste the Power, and basically it wants you to lick a 9-volt battery and feel it tingle. So I'm not going to lick a battery on here. I don't recommend licking a battery, especially anything other than a 9-volt battery. Don't lick anything bigger than a 9-volt battery. I would not even recommend a fully charged 9-volt battery. Let it die a little bit. But while your tongue's wet, it will tingle more than if your tongue is dry. When you touch a 9-volt battery to your tongue, you get a little tingle in your tongue, and that's basically your tongue's acting like a small resistor, and it's allowing electrons to flow from the battery through your tongue to the negative side of the battery in conventional current flow, from the positive to the negative. And we'll take a look at the characteristics of this battery, and we'll see. We'll take a look at the voltage of it here. So basically, this is a meter. These are meter leads. This meter has millivolts DC, regular volts DC, voltage AC. It can measure frequency, continuity, capacitors, diodes, ohms. It can do microfarads and capacitors, milliamps, and up to 10 amps AC or DC. And then, as this meter doesn't do AC current, but it does do the microamps, which I like, and it's unfused. So if you blow, you don't worry about blowing fuses because they're kind of hard to get sometimes. So let's just take a look. We're gonna simply measure this probe. If we look on the battery, the larger contact's the negative, and the smaller contact's the positive. So we're gonna touch these two like that, and we get 9.25 volts. So this is pretty much a fully charged battery, a little bit down lower. And this is an alkaline battery, so more likely it has 6 cells that are similar. They're cylinder shaped like a AA battery, but instead of AA, they're quadruple A, and they're stacked 6, 3 by 2 in here, and they're all 1.5 volts, and that's how they get the 9 volts. And that's basically how a 9-volt battery works. People think 9-volt batteries are better than like AA or AAA, but actually, AA batteries and AAA batteries have have a higher milliamp rating than one of these 9-volt batteries. So, it is small and compact for a 9-volt, but you're better off using 6 AA batteries for a project if you have the room for it than one 9-volt battery because it'll last longer. So that's basically, we measure the voltage of that. Just for the sake of measuring, I'll measure the voltage of this battery. And when you measure, don't touch your fingers on the probes because you'll be getting your own resistance. So 1.6 volts, so another fully charged battery. And then I have a Energizer battery that were on sale. We'll measure this. And this one's 1.3, so another fully charged battery. I thought I had one that was not fully charged. And 9.6, so. I don't recommend rechargeable batteries for any experiments in the book. So use regular standard batteries. Later experiments, you do damage a battery. So I'm going to make sure you turn your meter off so it doesn't wear down the power. And make sure if you are measuring amps and your terminals were in another port, always put it back to the voltage and ohms port, because if you tried to touch something while it was in the current, it is a dead short and your meter could blow up. That is not an exaggeration. It can happen. So that's basically, a dry tongue is going to tingle less than with a wet tongue. I have done that experiment before. I don't recommend doing it, but if you want to learn, there you go. Wet your tongue, lick it, and then dry your tongue off with a tissue or a napkin and lick it again. It will tingle less. Now, it talks about finding the resistance of your tongue, and we're gonna do that right now. So I'm gonna pull my meter back out and I'm gonna put it to the ohms section. I'm gonna make sure I'm in my ohms port, and if you look here right now, it's reading mega ohms. See if I can zoom in so you can see that. As you can see, I have it on the ohms port. I have it in the ohms port down here. And I am going to make sure my tongue's wet. And I'm going to keep the probes. I'm going to keep the probes about that far apart. About 3/4 of an inch. And I'm going to touch my tongue. So, touching my tongue with the probes, it was about 3 megohms of resistance. Now I'm going to dry my tongue off and touch it. And it read 4 mega ohms. So you can see that my tongue being dry had a higher resistance than my tongue being wet. And that is indicative of why the battery tingled more on a wet tongue, because more current was able to flow because of the lower resistance. It wasn't much lower, and my tongue still has a high resistance. That's why it wasn't harmful. If your tongue had a lower resistance, it could generally pass more current, but it doesn't. And to know how things are safe and how much current you're going to draw, it doesn't really talk about it. It talks about this next part slowly through the book, but I want to touch on it now, which is called Ohm's law. So I'm going to move this out of here, because that was basically the end of the experiment, just showing you that how resistance can change with wetness and dryness. So I just want to touch on one more topic here, which is called Ohm's law. See if this comes in here without being washed out. Okay. And Ohm's law basically states is voltage is equal to current times resistance, or V equals IR. And the best way for me when I was learning electronics to remember this is I would draw this circle and I would divide the bottom half, divide it in half, and then divide the bottom half in two. And I would write V up top for voltage, I down here for current, and R over here for resistance. And that way, no matter what I needed to figure out, whether it was voltage, resistance, or current, I could pick that value and see what was left. And then I would do that formula. X, for example, if I needed I, which is current, I would have V and R left, and V would be over top R. So it would be voltage over resistance, or I equals V over R. And then same principle for resistance. It would be resistance would equal V over I. Voltage over current, or R equals V over I. And voltage is measured in volts. Current, represented by I, is measured in amps, which is an A, which is amps. The abbreviation for amps is capital A. And then R is your resistance, and it's measured in ohms, which is this little omega symbol over here. So, and it's very simple math. If we look at this on a calculator, and we basically had 9 volts and 2 megohms on the tongue when it was set. So we had 9 volts divided by 2 million. And we enter. And we basically had, I want to say that's 5 nanoamps. It's 0.000005. So a decimal point and 5 zeros and then a 5, which is very, very minute amount of current. And if we do it on the dry tongue, 9 divided by 4 million ohms, 2, 3, and that's going to enter. And that was basically 2 nanoamps or microamps. So it was significantly less, but that little bit of current can damage you and can cause hurts. But I mean, that was at the most, it was 5 nanoamps or microamps, and it tingled. You felt that. So can you imagine, an amp or a milliamp, which is 1,000 times more powerful, or even an amp would be 10,000 times more powerful than that tingle on your tongue. So it would multiply very quickly on how much tingle you would get. But that was basically, I knew the resistance of my tongue because we measured it, and I knew how much voltage was in this battery. So I was able to divide voltage by current, or divide voltage by my resistance, and I was able to figure out how much current would flow. And I was able to determine touching a battery to my tongue is safe to do. And the math proves that. So that's Ohm's law. And this is just a little bonus information. This little symbol right here is what a resistor looks like. And like I said, it's measured in ohms. This symbol right here is a battery. It's measured in voltage, and it's got the longer leg is a plus, the shorter leg is a minus, and this is one cell of a battery. And if we were to draw, say, a 9-volt battery, we would have 9 of these cells stacked up, or 6 of these cells stacked up at 1.5 volts each to give us 9 volts. And then here's just a simple circuit showing that the battery provides the voltage, the resistor applies the resistance, and the flow of electricity, the actual flow of the conventional electrons through the circuit, is the amperage, which is your I. So this will come in pretty much every experiment. We would use some form of Ohm's law, and there's also a formula for figuring out the power rating, how many milliwatts or watts something is producing or is giving off in heat. And we'll cover that in later videos. So that's experiment 1 in the Make Electronics. I hope you enjoyed it, and stay tuned for future videos. If you have any questions or concerns, leave your comments down below. For Crazy Gamer Games, I'm the Crazy Gamer. You guys have a great day and have fun with electronics.